So today we are going to talk about Riemann sums. Okay. So again, um, either way you want to listen to this, put your personal headphones in and listen to it. If you're in the classroom, or one of you can log in and put it up on the board in YouTube, and I will send that link in our Canvas if you need it. But remember, you can just probably search BC T6L or T2L6, and it should pull up that video. All right, so let's get right into it. All right, so remember we talked about Riemann sums in AB, and that's where we found the area between the curve and the x-axis by dividing the region into geometric shapes, rectangles, and trapezoids, and find the sum of the areas of those shapes. All right, so if we do a left-hand Riemann sum, all right, so a left-hand Riemann sum means that the left point of the rectangle or whatever it is, okay, is on the graph. All right, so we're only going from 1 to 7 here. All right, so that is from here to here. All right, so I want the left side to be on that. Okay, and they are subintervals that are 2 units wide. So I'm going to go over 2 units from there. So there's 1. All right, and then I'm going to do another one. So I've got to go left point over 2 units. Drop that down. And then a third one, left point over 2 units, and drop that down. So there are our 3 rectangles that would be made to estimate this sum. Now, we do have a width here, each one of these, of 2. That's what we talked about. All right, so we are doing from 1 to 7, the interval from 1 to 7 of f of x dx. Okay, so basically we're just adding all of these up. So we do know that since we do have a uniform width here, we can pull that 2 out. All right, so then our height here is going to be 2, 4, 6, 8. That one's going to be 9, and that one's going to be 7. So 8 plus 9 plus 7 gives us a sum of 48. All right, now when you do the right-hand sum, remember the right point is what is on the graph. Okay, so again, we're going from 1 to 7, and we're doing intervals of 2. So there we are. Okay, so the right point, so I'm going to draw this right line up to the point and then make my rectangle. The right to the point and make my rectangle. The right side to the point and make my rectangle. All right, so same thing here. We're going to go from 1 to 7. So in this situation, again, our width is still 2. And then we got a height of 4, a height of 3, and a height of, it's probably actually a little bit further up there. It should be a little bit more than 4. I have 4.5 on my paper, so just be, all right, so we're going to go 4 plus 3 plus 4.5. Just humor me. All right, and that is going to give me 23 as my sum there. All right, and then the last one over here, midpoint, means you want the middle point to be on the graph. So again, we're going 1 to 7, intervals of 2. So I want the middle point to be on the graph. And we're just estimating here, so I'm not going to be super picky. So we're going from 1 to 7, f of x dx. And we're at, again, we've got 2, and we'll say 7 plus 2 plus 6 is going to give me about 30. All right, now, obviously, if we had the same shape here, okay, then we would see one should be closer to the actual value. If we did left, right, so forth, midpoint, we should get closer and closer to the value. But we did 3 different shapes here, so they're not supposed to be the same value at all. Okay, All right, example number 2. The profit for a small company is recorded over a 1-year period. The profit for every third month is shown in the table. Approximate the total profit using a trapezoidal sum with 4 sub-intervals. Okay, so the first thing I need you to remember, trapezoid formula is 1/2 base 1 plus base 2 times our height. We're doing 4 sub-intervals. So boom, 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 boom. And those are intervals of 3. So our height for each one of those is the 3. Okay, so remember constants can come out. So let's talk about total profit. Okay, so if I was to have the 3 here, right? So that would be 3 halves. So I'm going to pull the 3 halves in front, base 1 plus base 2. All right, so remember, so if I'm looking at the first subinterval, it's going to be 18 plus 22, base 1 and base 2. Then I go to the second subinterval, it's 22 plus 20. Then it's 20 plus 26, and then it's 26 plus 14. So remember, the two ends only happen once, and the middles are going to happen twice. So it's going to be 18 plus 2 times the 22, 2 times the 20, 2 times the 26, and 14. All right, adding all this up, you can do that without a calculator. So that's 44 and 40 is 84, and 52, 84 and 52, 18 and 52 is another 40. So 124, 140. Okay. All right, and then if you multiply that out, you do get, my calculator's dead, so I have to use Old Faithful. Oh, wait, maybe not. Here we go. Okay. 252. Okay, but it is in thousands. So make sure you don't just write 252 as your answer. It's going to be 252,000. All right. Next page. Okay, so now we're going to jump into definite integrals. And remember, it does say using a calculator. All right, I'm not going to dive into these very much because y'all can do these very easily on your own. But Math 9 is our integral. Okay, so we would go from -2 to 2. And it is 2 minus x dx. And we get 8. Literally, you're typing these in just like you see them. Okay, so go ahead and do those on your own. So pause the video real quick, type all 4 of those in. Don't just write my answer down. Okay, pause the video, write those, type those in, get those answers, and then double check with my answer against that. Okay, so we did know the first one was 8. All right, and then you should get these numbers. Those should be what you get when you type those in. All right, double check them. Don't just take my word for it. All right, example number 4. We're going to use the interval from 2 to 4 of x cubed dx equals 60, 4 to 2, x dx equals 6, and 2 to 4 dx equals 2 to evaluate this right here. Okay, so here we go. Sorry, somebody else at my door. Okay, so if I do this, okay, ultimately I can do each one of these individually. Okay, so if I do that, 2 to 4 of x cubed minus 3x plus 7 dx would equal 2 to 4 x cubed dx minus, we can pull the 3 out front, 2 to 4 x dx plus, pull the 7, 2 to 4 dx. All right, now let's look at what we have. All right, we have 2 to 4 x cubed dx. We have that whole thing right there already. We know that is 60. Now, we have 4 to 2 x dx is 6. All right, so remember, if you've got to flip this, you've got to change this. So it's the negative of it. So it'd be minus 3. It equals 6 if it went 4 to 2, but it goes 2 to 4, so it's going to be negative 6. And then we know 2 to 4 dx, so that was this one. And then we know 2 to 4 dx is just 2, and then we got the 7 in front, so plus 7 times 2. So 60 plus 18 plus 14 should equal 92. All right. Example number 5. Use the given graph of f prime of x to answer the following questions. What is the value from negative 6 to 6 of f prime of x dx? All right, negative 6 to 6. All right, so let's talk about what we're looking at. 1, 2, 3, 4, 5. Negative 6 is here. And so it's the whole graph. Okay. All right, so let's look. We've got, this one's going to be that triangle. Got another triangle. And y'all, you can do this kind of however you want to do this. Remember, you can break apart whatever you want to do. All right, so let's see what we've got. From negative 6 to 6, f prime of x dx. All right, so the first thing I notice is these two triangles right here. We've got one that's below and one that's above. So those two triangles are going to cancel each other out. Okay, so I don't need to even write that out. I can, but I don't need to. Okay, so those are gone. So these are going to cancel out. All right, so now I'm in here. So that's going to be 3 times 3. All right, and then we have a quarter circle here. Quarter circle. So that's going to be plus 1/4 pi, and our r of this circle is 3, minus, because we're below, we got a half circle here, 1/2 pi, and our r is 2. And then we're just going to do this math. So that's going to be 9. That's going to be 9/4 pi, and that's going to be minus 4 to 2 pi. So if you simplify that out, you should get 9 plus pi over 4. All right. So that's Riemann sums, and now we're going to move to the fundamental theorem. Okay, so a reminder about the fundamental theorem. All right, we know that interval from a to b of f prime of x dx is the same as f of b minus f of a. All right, so we're still using this figure. All right, so if f of negative 4 equals 2, then what is the value of f of 4? Okay, so negative 4 to 4 is what we're talking about here. So we're going to go from negative 4 to 4, f prime of x dx would equal f of 4 minus f of negative 4. Now, we don't know the value of f of 4. We know the value of f of negative 4. It's 2. And we can find this using our Riemann sums, okay, or our sums in general. So we've got negative 4 to 4, right? So 1, 2, 3, 4, that's here. 2, 1, 2, 3, 4, that's here. So that's going to be the 9, that quarter circle again, and then instead of a half circle, it's going to be a quarter circle here. So we already had the 9. We knew that was from the previous problem. Then we know it's going to be 9/4 pi. And then again, instead of this whole semicircle, it's only going to be the quarter of that. So it's going to be minus a quarter of pi r squared, r being 2. So that's going to be minus pi. Simplify that out, you're going to get, pull the 2 over. So that's going to give me 11 minus, or 11 plus 9/4 pi minus pi would equal f of 4. And then if you simplify this, so that's going to be 9/4 minus 4/4 is going to be 11 plus 5 pi on 4 is our value for f of 4. So that's what you're looking for there. All right, so go ahead and try letter C. You have just a little bit to do that. So you're going this time from negative 5 to 2. So what you're looking at, negative 5 to 2. So that's going to be f of 2 minus f of negative 5. Don't sit there and wait for me. Start the process. I know how y'all work or don't work. So we're going to have a triangle. Oh, you can do a, no, you don't even have to do a triangle. No, you could do the triangle if you wanted to, because we're going to 2, right? You could do that triangle. You know this is 9. And then we're going over to 2. So you could do, since you already know that you've got this square here and a quarter circle, you could just add that triangle on if you wanted to. Or you could do a trapezoid. I think when I wrote my workout, I did a trapezoid plus the quarter circle, but you could do it either way. I'll do a trapezoid just because we haven't done one yet. Okay, so if I do a trapezoid, it's going to be 1/2. Base 1 would be 1, 2, 3, 4. And base 2 would be 1, 2, 3. And our height would be 3. Plus, and then we know this quarter circle was 9 pi on 4. Equals, we know f of 2 is 4 minus f of negative 5. So 7 times 3 is 21, 21/2. Plus 9 pi on 4 minus 4 is going to equal negative f of negative 5. right, so 21, that's going to be 8. 21 minus 8 is 13 plus 9/4 pi is the negative. So that means our value for f of -5 is going to be negative 13 minus 9/4 pi. All right. So, oh wow, there's only 3 pages today. Okie dokie. Evaluate from 0 to 4. Now we've got a piecewise function, but we're evaluating fundamental theorem from 0 to 4. Okay. So you got to look at your little pivot point here. So notice our pivot point is happening here at 2. Okay. So that's where we're going to have to make our intervals from. So if I want to go from 0 to 4, I'm going to have to do from 0 to 2 and 2 to 4. Because they're not the same equation, so we've got to break it apart. All right, so let's jump into that. So 0 to 2 is x plus 4, because that's less than 2. So x plus 4 dx plus 2 to 4 is negative 2x plus 16 dx. All right, so let's get this done. All right, so if I take the antiderivative of x plus 4, it's going to give me 1/2 x squared plus 4x, and that's a definite integral from 0 to 2, plus antiderivative here is going to be, that becomes a 2, so negative 2 divided by 2 is negative 1x squared, so negative x squared plus 16x, and again, that's a definite integral from 2 to 4. Sorry. All right, so now you're going to plug in the numbers you need. So I'm going to do 2 first, right? All right, 2 squared is 4, half of 4 is 2, 2 times 4 is 8, so that's 2 plus 8 for that one, minus, and then if you plug in 0, you get 0, plus, all right, if I plug in 4, I get negative 16 plus 64, minus, if I plug in 2, that's going to give me negative 4 plus 32. All right, so this is going to give me 10 plus 48. That would give me 28, so minus 28. So 48 minus 28 is 20, plus 10 is 30. All right, example number 7. Given below is a table that shows values of f of x and its first and second derivatives at selected values of x. What is the value of the integral from -1 to 3 f prime of x dx? So remember, using the fundamental theorem, the integral from -1, definite integral from -3 to 1 of f prime of x is the same thing as f of b minus f of a. So f of 1 is -2, minus f of -3 is 4, and -2 minus 4 is -6. We love chart problems. All right, what's the value of the integral from -1 to 3 f prime of x plus f double prime of x dx? All right, well, let's think about it. If we apply the antiderivative here, okay, if I apply the antiderivative here, since it's a definite integral, all right, the antiderivative of f prime of x would take us one above, which is going to be f of x, plus the antiderivative of f double prime would be f prime, from -1 to 3. So now we're going to evaluate that definite integral. So we're going to start with f of 3, which is 1, plus f prime of 3, which is 2, minus f of -1, which is 0, plus f prime of -1, which is 4. And simplify that out. 3 minus 4 gives me -1. All right, -1 to 5, f double prime of x. Okay, so we can still use the fundamental theorem, right? So if we did f prime of x is f of b minus f of a, then f double prime would be f prime of b minus f prime of a. And now we just evaluate with the table. Love tables. All right, f prime of 5 is 0. F prime of -1 is 4. And 0 minus 4 is -4. Last problem. All right, the velocity of a particle moving along the x-axis is given by the function v of t equals cosine t, where t is the time in seconds. When t equals 0, the position of the particle is 2. What is the position of the particle at t equals pi on 2? Okay, so remember, velocity is the derivative, right, of position. Okay, so we're right here. This means t equals 0, so that means p of 0 is 2. So now let's talk about this. If we do the antiderivative from 0 to pi on 2 of velocity, which is the cosine of t dt, that would equal the one above it, which will be position. So the position of pi on 2, f of b minus f of a. Because remember, it goes position, velocity, acceleration. So this is our function, this is our derivative, this is our double derivative. Okay? All right, so if we take the antiderivative here, so we know the antiderivative of cosine is going to give me sine from 0 to pi on 2 equals, we don't know p of pi on 2, but we do know that p of 0 is 2. Now we're going to calculate that definite integral. All right, so if I put in, I'll write it out for y'all non-unit circle people. Okay, so it's going to be the sine of pi on 2 minus the sine of 0. All right, sine of pi on 2. So we're up at the top, right? Sine is your y number, so that is 1. Sine of 0 is over here, 0 equals, so 1 plus 2 is going to give me 3. So p of pi on 2 is going to equal 3. All right, so you need to work on, and there's I think if I'm not mistaken, the worksheet is actually on the back side of this page on your notes, but I do have a actual worksheet that's detached that I will leave as well, so you can do either one of them. I just didn't realize it was on the back of your notes when I ran them, so you do have both copies of that. But that is what you need to be working on right now. I'm not waiting, so go ahead and get started on that, and I will see you all shortly.